Hi Calculus 1 students. So in my series, extra examples from for the midterm, okay, this one is in section 3.2. So you're supposed to use the product and the quotient rule, as well as the rules that were presented before that. So there's no chain rule in there yet. But again, the example is important because of the conceptuality of the question. So it was an example given a while ago in the final exam of fall 2013. So it's a little bit old, but it's a difficult question. So that's why I want to do it. At which values of x do the tangent line to f of x that's equal to x over 2x minus 1 passing through the point negative 7 or 1 touch the curve? Okay, here I will draw the curve that's inside my lecture notes just to show you how you should think about the problem. Okay, so this function will look something like this. So it has an asymptote at 1/2, but the way it looks is actually not that important, to be honest. Okay, so it does have like these two asymptotes. Okay, and it's going to look somehow like this. Yeah, and it's going to pass through 0, so something like this. And it does look like that. The point is that you have like a point which is given. It's this like negative 7, 1, which maybe will be here. And you have tangent lines. So there's a tangent line, for example, right here, that will pass through the point, and you're interested, well, okay, where is this point? And likewise, somewhere along the curve, you will have like another point here that is also passing through this negative 7, 1. So actually, the lines here should be plural, because in this particular problem, you will see that there are two tangent lines that is passing through this point. Okay? The idea of the problem, the way we're going to solve it, is that there are two ways we can find the tangent line. And both of them will give us an expression of x that we will set equal to each other. Okay? So, two ways to find a slope of the lines. Okay, one is to take the derivative, right? So that's going to be the slope of, so actually let's write something similar to what we always write. The slope of the tangent line at x f of x. Okay, so we know that this is f prime of x. So this is like the first step in the problem. But the second step is that this will turn out to be the same slope as the slope of the line through x f of x and the given point, so the negative 7, 1. And this slope will be given by delta y over delta x. So in other words, and I will take f of x here to be the second point, just because it will turn out to be easier. So it's f of x minus 1 over x minus the negative 7. So the idea is we're using what is called the two-point slope formula. Okay? And obviously, then what we're going to do is we're going to set them equal to each other and solve for x. So actually, these two slopes are equal. So force these two slopes to be equal. There you go. Force these two slopes to be equal, and solve for x. Okay, so now we have a plan. Let's follow it. So number one, f prime of x. So here we have to use the quotient rule. Okay, so let's actually write x over 2x minus 1 like this, prime. And then don't forget the quotient rule. So you take the derivative of the top, 1, times the bottom, 2x minus 1, minus the top, times the derivative of the bottom, so minus the 2 here. And you divide by the bottom squared. Okay, so the 2x minus 1 squared. Okay, so here, not a hard derivative, but you do have to solve an equation with it. So my recommendation here is to simplify it as much as you can. And you will get negative 1 over 2x minus 1 squared. Step number 1, done. The step number 2. Okay, so what we want to do is to compute. Okay, so what is f of x minus 1 over x plus 7? Okay, so in other words, I'm computing what's over here. You guys see? Obviously, we want to replace f of x by what it is. So f of x is x over 2x minus 1 minus 1. Now be careful, because what you're going to have here is what I like to call a wedding cake, right? A fraction inside of a fraction. Okay, should we simplify this? Yes, we should simplify this, okay? But we need to be careful as how we do it, because we don't want to remove points from the domain of this function. That being said, we can safely multiply the top and the bottom by the least common denominator. And this is simply because even if this happens to be 0, the fact that we have it on the global denominator will make it so that it will still make the function undefined. All right, so here we go. Don't forget about this technique, very useful. Here you're multiplying, so you cancel this and you have x at the top. And here you don't cancel anything, so you will have here your negative in bracket 2x minus 1. And this is obviously over x plus 7 times the 2x minus 1 that you also multiply at the bottom. After that, obviously, simplifying the numerator will do it. Okay, so you will have here negative x plus 1 over all of that. Okay, so now let's erase, let's erase this. We're almost done. Because obviously now step number 3 is to set these two things equal to each other. Okay, so we want f prime of x to be equal to f of x minus 1 over x plus 7. Okay, so literally we take the two expressions we found, so negative 1 over 2x minus 1 squared. That has to be equal to negative x plus 1 over this big fraction. So x plus 7, 2x minus 1. Okay. From there, we are solving this equation. So what we need to do is to cross multiply. So it means that the new top will become, and okay, here I'll go slightly slowly, okay, just because I'm scared of you missing out something. So you have like x plus 7 times, so cross multiply, remember what it is. It just means like send this denominator here and send this denominator there. So actually, I'm not going to cross multiply. I will just, oh yes, okay, good. So what I will do, I'll send the x plus 7 over there. Okay, so I'm okay with that. I will keep the 2x minus 1 here. And the reason is simple. I know that it's going to cancel. So in other words, I'll move the 2x minus 1 squared here, divided by 2x minus 1. So it's just rearranging. There's not much to say here. But then that's it. Like you have like exponent 2 and exponent 1. So that will make it so that you have negative x minus 7 that is equal to 1 minus x, 2x minus 1. Not sure I'm going to have enough space, so I'm just going to continue to write underneath. I don't need this anymore. Okay. Then you need to expand this, obviously. So negative x minus 7 is equal to, what are we going to get? Negative, oh, actually, let's go in order. 2x minus x. Oh, shoot. Okay, so 2x minus 1 minus 2x squared plus x. Okay, that's what we have. And then we need to combine the like terms in the appropriate way. So let's send the 2x squared on the other side. And what about the x's? Okay, this we have to be careful. So we're going to have negative x minus 2x minus x. So minus 4x. And then we have negative 7 plus 1. So negative 6. This is equal to 0. After that, obviously factor cancel. Well, okay, so factor and use the zero product property. So you pull the 2 out. Factor this trinomial. It's going to end up being x minus 3, x plus 1. And here you are. You are done. X is equal to 3 and x is equal to negative 1 are the two values of x that we were looking for. Awesome. All right. I hope this was helpful. I have maybe 1 or 2 more videos for you, and then see you there.